Good morning, children. So today's topic is laws of operations on sets. So for any subsets A, B, C of the set U, that means A, B, C are contained in U. So if you see here, U is acting as universal set for A, B, C. Then the following laws are satisfied. So number one, laws of union of sets. So A union B is always equal to B union A. This is called commutative law. Then in bracket A union B, then union C is equal to A union and in bracket B union C. This is called associative law. A union A is always A. A union empty set is A. A union universal set is universal set. Then laws of intersection of sets. A intersection B is equal to B intersection A. This is called commutative law. Then in bracket A intersection B intersection C is equal to A intersection and in bracket B intersection C is always equal, and this is called associative law. A intersection A is A. A intersection empty set is empty set, and A intersection universal set is A. Okay. Next is distributive laws. A union, then in bracket you have got B intersection C. This will be equal to in bracket A union B intersection in bracket A union C. If you have something like this, A intersection and in bracket B union C, then this is equal to A intersection B union A intersection C. Next, De Morgan's laws. Here it says A union B whole complement is equal to A complement intersection B complement. A intersection B whole complement is equal to A complement in union B complement. Okay. Venn diagrams. In order to express the relationship among sets in perspective, we represent them pictorially by means of diagrams called Venn diagrams. In these diagrams, the universal set is represented by a rectangular region and its subsets by circles inside the rectangle. We represent disjoint sets by disjoint circles and intersecting sets by intersecting circles. So let us try to understand. So here number one, Venn diagram for universal set. So here I have taken a universal set, this, and one set A, which is this. Now what we'll do is this set A will be represented by a circle, okay, and inside the circle we'll write the elements of that set A, okay, and this set A will be contained in the universal set and that will be represented by a rectangle, okay, and we'll write down the remaining elements of universal set, okay, which are not in A outside the circle, okay. So in total, if you see 1 2 3 4 5 6 7, these elements are lying within the rectangle. So these elements are these are the member of universal set, and the one which are lying within the circle, these elements are in set A, okay. Venn diagram for A union B. So here I have taken two sets A and B separately. If you represent A and B, then we will be representing it like this, okay, and within the circle it has got the elements, okay. Now A union B means we'll write down all the elements, okay, of A and B without any repetition, okay. So here A union B is represented by this, by two circles, okay, and intersecting each other, and in the common region you'll write all those elements which are common in both A and B, okay. So here for set A and B, if you see 2 and 3, okay, these two elements are common in both, that's why 2 and 3 are put in this common region, okay, and 1 and 4 is separate, okay, it is it is not in set not in this circle B, okay, and 5 and 6 is not in set A, that's why this is only in this circle, okay. And so whole thing shaded over here to represent union of A and B. Next, Venn diagram of A intersection B. So you have got two sets A and B. A will be represented this, B will be represented this, okay. And A intersection means we have to write all the common elements of A and B. So here what we'll do is we will only shade this common region, okay, and in this common region 2 and 3 are lying, okay. So this is the common region this is the intersection of A and B. So all elements written in this region are the members of A intersection B. Venn diagram for disjoint sets. Okay, so the circles are not intersecting, therefore so here you can see I have taken two circles. That means this circle represents set A, this circle represents B. Since they are not intersecting anywhere, that means they have no elements common in them. Okay, the Venn diagram for A minus B and B minus A. Okay, so A minus B means what? It is a set of elements which contains only elements of A, and B minus A is a set which contains elements of B only. Okay, so here two sets are there, A and B. Okay, so this region, setted region, okay, this represents A minus B because this has got only the elements of A. Okay, and B minus A is represented this way because this shaded region contains only the elements of B. Venn diagram for A complement. Okay, so this rectangle represents the universal set. Okay, and this circle is a set A. So all the elements lying outside this circle A, okay, will be A complement. Venn diagram for symmetric difference of A and B. So symmetric difference of A and B in Venn diagram, this is represented this way. So this circle represents set A, this circle represents set B. So symmetric difference of A and B will be this shaded region. Okay, so here the intersection part is excluded. Okay, now some important results. Suppose you have got three sets A, B and C, and they are finite set. Then number of elements in A union B will be given as number of elements in A plus number of elements in B minus number of elements in A intersection B. Number of elements in A minus B will be given as number of elements in A minus number of elements in A intersection B. Number of elements lying in the set B minus A will be equal to number of elements in B minus number of elements in A intersection B. Number of elements in symmetric difference of A and B will be number of elements in A plus number of elements B minus 2 times number of elements in A intersection B. Okay, and number of elements in A union B union C will be given as this. Okay, so now let us see a few questions. Okay, question number 14, exercise 1-5. Set A has 10 elements and set B has 16 elements. What can be the maximum number of elements in the set A union B? Find also the maximum number of elements in A intersection B. So here given that number of elements in A is 10, number of elements in B is 16. So we know that number of elements in A union B is given by number of elements in A plus number of elements in B minus number of elements in intersection of A and B. So A I know the number of elements in B. Okay. Now when number of elements in union A union B will be maximum? When this becomes 0. Okay. If this becomes 0, then A union B will have maximum elements. Okay. So A union B will have maximum number of elements if number of elements in A intersection B is equal to 0. So maximum in A union B will be number of elements in A plus number of elements B. That means 10 plus 16 equal to 26. So maximum number of elements in A union B can be 26. Okay. Next is asking what? It is asking find also the maximum number of elements in A intersection B. Okay. So here, as number of elements in A is 10, that is less than number of elements in B, that is 16. Okay. So here 10 is less than 16. So A can be subset of B. Okay. So A can be subset of B. So if you take intersection of A and B, then you will get whole of A. Yes. So in that case, your intersection will be maximum. Okay. So then we'll have maximum number of elements in A intersection B if A is contained in B or A intersection B is equal to A. So maximum number of elements, okay, will be this, equal to 10. And minimum number of elements in A union B will be, like here we know that number of element in union is given by this. So when this number of element in union will be minimum, when this portion becomes maximum. Yes, when you subtract more, then this will become minimum. Yes, so minimum number of elements in A union B will be this, number of elements plus number of element in B minus maximum number of elements in A union A intersection B. So you get 16. Next is question number 14. In a group of 60 people, 30 speak Hindi, 25 speak English, and 10 speak both Hindi and English. How many speak at least one of these two languages? How many speak neither Hindi nor English? So here total number of people are 60. Okay. And let H be the set of people who speak Hindi. So number of people who are speaking Hindi is equal to 30. And suppose E denotes the set of people who speak English, then it's given that number of people speak English is equal to 25. And next is saying that 10 speak both Hindi and English. Okay, that means they are common. Okay, if I consider H intersection E, that means I'm taking set of people who speak both English and Hindi. So it's given that number of people who speak Hindi and English is equal to 10. That means number of elements in H intersection E is equal to 10. Now we know that number of elements in H union E will be equal to number of elements in H plus number of elements in E minus number of elements in H intersection E. So put the values, you will get 45. So there are 45 people who speak at least one language. Okay. Now they are asking how many are there who do not speak any of the language. So number of people who speak neither Hindi nor English will be number of elements in H union E intersection. Complement. Number of elements in H union E complement. So here in a universal set, actually total people are 60. Okay. So that set will be considered as universal set, and it has got 60 elements. So 60 minus 45, that means 15. So 15 of them are there who do not speak English and nor do they speak Hindi. Okay. So this is all for the sets, and from this chapter they hardly ask 2 marks and the questions will be easy one. Okay. So this is all.